Okay, great. Welcome everybody. Let's wait a couple of minutes for people to get to join. Let me go ahead and share my screen in the meantime. Okay. So looks like we got some people in. Welcome everybody. I'm Fabio. I work at Hopsworks, and today we're going to be discussing about how you can leverage the data that you have in your data warehouses like Snowflake, BigQuery, and Redshift with a real-time feature store like Hopsworks essentially. Okay, some people joined, so let's go ahead and get started. Today we're going to focus on three main data warehouses. The one that we have support for in Hopsworks, which is Snowflake, Redshift, and BigQuery. Both of them are cloud-native data warehouses, and are used across many enterprises to do both power analytics, but also to power machine learning workflows, right? So if you look at like a typical machine learning workflows that we see out there in the field, by talking to customers, users, and so on, you can see that data scientists usually, again, use the data warehouse as a data source. Data warehouse serves multiple internal customers. Usually, it serves the the analytics team, dashboards, data science team, and so on and so forth. So what they usually do is basically they plug into their data warehouse, run the SQL query with the feature engineering code, get out the data, and train a model and productionize the model. This workflow has some limitations, I would say, and so there are some some challenges, I would say, that most of the scientists we talk to actually encounter, right? So one, obviously, it's the historical data, right? Again, this is like generic. This is something generic that we see. Obviously, there are several solutions to several ways to solve this problem. Hopsworks we see later being one of them. So essentially, what oftentimes happen is that the tables and the data in the data warehouse actually doesn't contain the history, right? So for instance, you have a table containing the status of a customer, but it doesn't necessarily have the historical changes of that customer, right? So you might have the customer profiles, but you don't have the customer profile, how the customer looked like, a month ago, 6 months ago, so on and so forth. So it makes it impossible. Like there is no way for you to have the history of that customer. So it's up to you as a scientist to actually build and that history, right? So then we come into like how do you do that, right? So sometimes you get people coming to us looking into the feature store and the Hopsworks feature store because they try to actually use it as a materialized table in Snowflake or Redshift and so on. So they basically keep appending to that table. That brings two challenges by themselves, right? So the one is obviously cost, right? So you're accumulating a lot of data in a data warehouse, and that obviously increase the bill. The other aspect that makes it challenging is that oftentimes you want to add additional features. You might want to experiment with features. Like one of the patterns that we often hear about is it's basically, okay, well, I'm trying out the features just to try them out and see which one works best, and then out of the 100 features I might select 10 features or something. So when it comes to maintaining the historical view, it becomes quite complex, right? Because all of a sudden it's like, how do you split them? Are you going to keep one single table with all your model fetching from that table, or are you going to split up? If you keep a single table with all the models reading from there, how do you handle stuff like backfilling? How do you handle additional features, and so on and so forth? And if you have multiple tables spreading around the data warehouse containing multiple data and so on, the other challenge that comes up is lack of visibility, right? If you're a new data scientist in the company, or if you're building a new model, how do you know which features are already available for you to just use them, right? They are not in a single table; they are multiple tables. You need to kind of dig them out and so on. And with that, there is a lot of other metadata, like how the tables are built, how the features are built, how the features from which table they are consuming, when they have been updated, and all this kind of metadata that's useful for you as a data scientist to know exactly whether or not you can use that feature for your model and so on. Another big problem that the data scientists usually tell us about is they are unable to reproduce experiments, right? So again, data warehouses within a company usually serve multiple internal users, right? So they may serve analytics, might be powering some dashboards, and so on and so forth. So the challenge there is that data in data warehouse gets updated, right? And that kind of breaks breaks the reproducibility of the experiments, right? So it makes it hard for you to go back in time and look at like how was the data a month ago, 2 months ago, and so on and so forth. Data warehouses, some of them have like Snowflake apps support for time travel, but if we look, as we'll look later, that will have Hopsworks comes as a first-class citizen, so you can keep track of how data has changed over time and be able to go back in time and reproduce an experiment in the past. Finally, probably the biggest one, right, where people look at feature store and Hopsworks for complementing the data warehouses and integrate with the data warehouses, is actually support for online use cases, right? So if you have a model that needs to be serving requests to user behind a REST endpoint at low latency, you need to give that model context for making decisions, and that context needs to be available in relatively low latency. And when, like, obviously that depends on the use case, but like usually it's in the like single-digit millisecond latency or that kind of realm of requests, right? And data warehouses are not essentially designed for that, so they don't really work with this type of use cases. So you need to move data around, and when you start moving data around in dedicated systems, you always have the problem of like how do we avoid having like training and serving skew essentially. How do we keep data consistent so we know which features are being used for training, which features are being used for serving, and so on and so forth, right? So we believe that Hopsworks Feature Store solves all those 4 challenges and can be used to improve the data science workflow end to end, from building models and productionizing models. So I'm gonna be looking at like some of the capabilities and some of the connectors that we have integrated with Hopsworks. The connectors and everything that I'm going to be showing today is going to be available on app.hopsworks.ai, which is our like free serverless platform. You can just register there. You will find the latest tutorials. You'll find a way to reach out to us and ask questions and make and basically chat with us. It's a free environment. You can get started. It's not time bound in terms of quota, so you can keep it running as long as you want, as long as you need, to build cool examples. So in particular, when it comes to Hopsworks, the core idea is basically to be able, and the feature store, its core idea is basically to be able to bridge, let's say, your enterprise data. And in this webinar, we're going to be focusing on, we're focusing on cloud data warehouses. But you know, if you have data lakes, if you have on-prem warehouses, like could be Oracle, all these concepts and ideas actually are still valid, right? And bridge that gap with your like enterprise AI effort, whether it's model development, whether it's online applications, fetching requests, and so on and so forth, like that kind of build up that bridge and make sure that the data gets consistently between the two essentially. The way we do it, Hopsworks has several components that are part of Hopsworks. I'm not going to dig too much in details into this. Again, we're going to be focusing this talk mostly on the feature group side of things. I've done some previous webinars, and my colleagues have done other webinars as well, and blog posts and so on and so forth, to discuss the all the different components, how they work together to provide the Hopsworks functionality, the different workflow for the different personas. Like if you're a data scientist, if you're data engineers, might be using different parts of the platforms, and how those work, those platforms work together essentially. So in our case, we're gonna, as I mentioned, we're gonna be focusing on the part on the left side, so the enterprise data sources and the feature groups, right? So in particular, like what we want to add at the end essentially is the following: data basically also gets knowledge about the data, and we see later on whether it's on Redshift, Snowflake again. If you have open data warehouses or like generally JDBC databases and BigQuery, and then the models do not necessarily interact directly with, and the scientists building the models do not necessarily interact directly with the data warehouses, but they interact through Hopsworks, and fetch data through Hopsworks essentially. And the same thing happens on the right side of the picture, where we are productionizing the models. Hopsworks becomes the center and becomes the entity that provides the models with the necessary logic and necessary context for the models to make real-time predictions. The way you actually configure Hopsworks is with external storage connectors is by we have two type of use cases, right? The first use case is external feature groups, and the second one is called import feature groups. The reason we have two is that they kind of satisfy two different constraints and two different use cases that customers and users come to us with. So we want to support both to be flexible and adapt to the workflow that the customer has essentially. So if we look at both of them are pros and cons, by the way. So now I want to look at like both how they work on external feature groups and internal feature groups and import feature groups, and how they and what's the pros and cons of both of them, and making sure that you make the right decision on which one to use essentially. Right. So the first one is external feature groups. The basic idea is that you are bringing your table or your SQL query that does the feature engineering into Hopsworks, and you're essentially mounting it as an external drive essentially, right? So the data never gets moved into Hopsworks, right? The basic idea is that you are the scientist. You are basically registering a given query or a given table as here's the data source, here's the query to run to compute my features, and that's there you go. That's everything you essentially need for external feature groups. And what happens is that when the data scientist needs to use a feature, it talks to Hopsworks and say, well, I need feature XYZ. And Hopsworks, what it does is basically goes to the underlying storage connector, execute that query, and return back the result to the user essentially, right? So there's no essential data movement there, and you get a nice visibility into the existing pipelines that you might already built. This is actually the reason why we built external feature groups in the first place, basically allowing you to basically say, okay, well, I'm bringing Hopsworks within the company. I already have a bunch of pipelines. I don't want to necessarily, from day zero, rewrite those pipelines. I can just basically plug them into Hopsworks, and data scientists have like one-stop shop for basically pulling out the features that they need to build their models, right? So that's the typical use case for external feature groups, like implementing basically and including existing pipelines into Hopsworks. There are several downsides, and to be honest, the external feature groups don't really solve the challenges that we were mentioning before. So it's still a SQL query, so you need to be able to build the history yourself, either through like some complex SQL query, or by having some external table on the external data warehouse to be able to fetch it, right? Again, reproducibility is not guaranteed. This is because the data, like every time the feature is being used, the query gets executed, So if the underlying data has changed, then obviously the feature is going to be different, right? So there is no, the external feature group don't really have that mechanism to be able to detect that change, right? And again, since the data is not moved into Hopsworks and is only available in data warehouses, external feature groups are not don't have support for online use cases. So if you want to serve that feature online, that becomes a problem, right? So what we did essentially is, what you can do is basically, okay, we're gonna import data into an Hopsworks feature group, right? In this case, the downside is that you're moving data into Hopsworks. It's not really a downside, like we don't see it as a downside, but like we get this comment a lot from customers saying, I want to avoid data duplication, and there is a I would say a good argument why this is not duplicated data. Oftentimes, while the source tables are the same, the source table cannot be modified to work with machine learning models, because they also need to be used by data analysts and dashboards and so on and so forth. So in a sense, anyway, the moment you need a feature, you need to apply transformations, whether it's aggregations, whether it's transformation, normalization, and so on and so forth, that makes the data basically unusable for any other context, but actually building a model, essentially, right? So you're not essentially duplicating the data. Hopsworks now becomes responsible for that data. You get a bunch of benefits. The main one being, once data is in Hopsworks, then data can be stored at the same time on the what we call offline and online feature store. That allows you basically to use the same data for both building the model and actually serving the model in real time, essentially, right? So Hopsworks has built, and we'll see a quick example later on. Hopsworks has some nice API that allows data scientists to manage the two storages and basically make them transparent, and allow you data scientists to be able to say, okay, I've built this model with a set of features. I'm going to productionize this model, and basically you're going to be using the same set of features, and Hopsworks guarantees the consistency between the features used in training and the features used during survey. You're importing the data, and you can do that periodically with the periodic jobs, and with periodic jobs. And once you do that, you then automatically basically get a history for free, essentially. So if every day you are appending data from you take a snapshot of your data on data warehouse and you append it to Hopsworks, that basically that becomes basically your free history, essentially. You can reproduce experiments. As I mentioned, Hopsworks has native support for time travel. You can basically say, give me the data as it was X point in time in the past, like a month ago, 2 months ago, or something like that. And that basically allows you to reproduce a given experiment, right? So you basically can say, debug models and so on and so forth. There is a factor called cost reduction. Everybody we talk to, that's a big decision factor. Usually the pricing for Snowflake and Redshift and so on are quite high. That's not compared to Hopsworks, and so there's a significant cost reduction as Hopsworks becomes the center for storing those features. Not necessarily to build them, but to at least store them and make them available for data scientists. Okay, so that's kind of like the slides I have. What I would like to show you, and it's basically an example of how you can import some data from Snowflake and work with that data imported to build essentially the different components and productionize the model, essentially. I'm going to be focusing today on Snowflake, and you will be able to find online also the same pattern with Redshift connector and the BigQuery connector. So to be able to follow along, what you can do is basically go to app.hopsworks.ai. As I mentioned, that's our serverless free platform, and you can basically log into that. Let me just pull this away and go back to my own directory. So if you go to app.hopsworks.ai, that allows you to basically log in and you register, you create a project. I've already registered, already created a project, so I'm not going to go through the same steps. You can see all the tutorials here if you're going to get started with like some of the components, understanding what a feature group is, what a feature view is, how they work together, and so on and so forth. You can see we have a Colab notebook that you can basically open, basically click, run through, and hopefully you want to read it through, and so on and so forth. You can click for this session. We're going to click on Hopsworks. I also have an account open here on Snowflake. I am looking at the COVID-19 dataset that we're going to be using for this demo. So one thing we want to do is basically, the first thing we want to do is basically set up a storage connector, right? I already have one set up. I can just show you how it was done. You're going to select a Snowflake connector. You're going to give it a name, a description. You put your connection URL. And you create a username and password. So if you are an enterprise setting, that's usually a service account. And in this case, is my colleague account. You provide a database name, a schema name, and a warehouse name. So the database name, if you look at this table, for instance, is COVID-19. The table name the database name is COVID-19. The schema is public, and the warehouse is test. The warehouse is one. You can have other aspects. You can set up a bunch of properties based on the Snowflake documentation. You can also write an application identifier. Essentially, this is basically a tag that you can use if you're tracking pricing and you're tracking expenses in Snowflake. Every query run by Hopsworks is going to be tagged with a specific tag that you specify here, and you will be able to see that in your Snowflake dashboard, essentially. Okay, so I have already created one, so it's already up and running, created. I can go to feature groups, and again, I have created a bunch of them already, but I can click on the import page, right? So what I'm going to do here essentially is I'm going to select the Snowflake connector that I want to use. I'm going to be looking at, so let's say we import the CDC testing table. I'm going to just select the table name. I'm going to call it, I'm going to give a feature group name, so CDC testing, CDC testing data, COVID-19. I'm going to be looking at the, let me see what's called name available here. This is my primary key that we're going to be using. Go. And then I'm going to use an event time table. So if you want to look at, if you want to know what the event time is, have a look at the previous blog posts and webinars on understanding how the event time works and how we join table together and make the point in time joins correctness between different feature groups. I'm going to make this feature available online, and I'm going to also enable statistics that we can see. So I can, once this is done, I could also specify a partition key. Table is quite small, so a best practice if you have like large amount of data, then it is to specify a partition key. I'm going to go ahead without for the moment because it's a quite small table. And then this is basically going to kick off a job for me, and it's basically going to go on Snowflake. It's going to basically execute the query and basically register the output with Hopsworks. And you can see here, I've already created two of them. I have the Apple mobility table registered with all the information about Apple tracking movements, and also the European CDC weekly data and so on. So once it is here, it's basically logged and registered with all the features. Each column becomes a feature. You can obviously have a preview of the data. Just a second. Pops up. In the meantime, let me also got just oh yeah, it was pop up. 1 second again. Yeah, so you can basically see all the table that are running and different values. So you can get like an idea of the data. you can see the statistics. Those are automatically computed because we selected them. And also correlation should be available for numeric columns. And we can also look at the history of the data. So, for instance, in this, we just imported the feature group, and we created 30 new rows. We computed statistics and so on and so forth, right? So, and the same happens for the other feature group. So for the this is being created right now. So I also have this app on mobility up and running. So what happens if I want to use them, for instance, right? So what I can do is I can jump on a notebook and basically go through the steps. I can basically just call up notebook, install Hopsworks SDK, and as a first step. Then the second step is basically log in, make sure that the notebook is logged in with app. So especially you call this Hopsworks login method, and you get the feature store object. But basically this requires you to generate an API key. You paste the API key, and then you're basically logged in. From then on, you can basically retrieve the two feature groups. You can specify a query. So here is basically selecting the features that you actually need for building a model. In this case, we're trying to see if there is, we can predict the number of cases based on some features from the Apple Mobility dataset. So I'm going to select all the features from the ECDC Global Weekly Feature Group, and I'm going to join them with some of the features available on the Apple Mobility feature group. And you can see here an example of being joined together. This query here, because data has been imported into Hopsworks, is not going to go in Snowflake. It's just going to read the data from Hopsworks. And at this point, I'm not making any feature engineering anymore. At this point, it's just a matter of like gluing together the features that are needed for my model. And then finally, you can basically create a feature view, which essentially means I'm registering the query above with Hopsworks itself, so I can use the same feature view for training my model as well as productionize my model and making the model available online. And you can see if you click it every time you create some entity in Hopsworks, those are registered and are basically available in the UI as well. So you can basically see those are all the features that my model is going to use, and from which feature group they are coming from. And then, if I want to create a training data set to train my model, I can go through the steps to create that training data set, and I can use that training data set to train my model, and then use again the feature view back to be able to set that model. If you are interested in how all the things work, the example notebooks, that you have on the Getting Started page just walk you through that step. So feel free to have a look at that again. Okay, so let me go back here. Online, you will find also the same steps for Redshift and the same step for BigQuery as well. So have a look online for those videos. Again, thank you all for joining. Now I'm going to take all your questions. If you have additional questions, feel free to jump on the public Hopsworks Slack, where me and my teammates are going to be there answering all your questions and guide you through any use case that you might be implementing and so on. Thank you very much.